Hi guys, Dash here, YouTube video lesson 1 over logarithms and exponential functions. Basically these help out with compound interest, and logs can also help you with getting rid of unwanted exponents. Exponential function equation that we use is n equals ab to the power x. Now n equals the amount after x time. The question now. It says, in 1777, Jacob de Haven loaned George Washington's army $450,000 to help support the Revolutionary War. Congress agreed to pay him a 6% interest compounded yearly. Okay. So what was the money owed in 1783? So let's insert all values in the appropriate area. Remember to add 1 to the growth rate because it makes it 1.06 rather than 0.06. Because if you just put 0.06, you'll only get 6% of the growth, and it doesn't contain the initial value. N equals the initial value, which was $450,000, times the growth rate. Always do 1 plus your growth rate. So since ours is 6%, and we have it in decimal form, we're going to put 1.06 into the time. So here, his first deposit was in 1777. His next one was in 1783. Six year difference. Let me put it like that. And then you can type it in your calculator. And that's your answer. Which n equals, this is the amount of money he'll have after 6 years. Okay, so part B says, when was 100 million owed on the loan? Now for this one we'll need to use logarithms because the x is in the exponent. Okay, exponents and logarithms work well because they essentially undo each other. The logarithm function undoes the exponential function as long as the base of the logs stay the same. So, n is what you want after when it's 100 million years, because you're looking for time and x. So n, 100 million. Equals your initial deposit, growth rate, like it's the same, and then time, which we don't know, is x. First we can divide the 450,000. You see that? Okay, now we have to take the logs of both sides because of the x here. Now watch what happens. Here I'll just use the regular log with a base 10 because that's the only log my calculator has. And we can actually cross out these zeros here. 1, 2, 3. Now take the log of both sides. This is what you get. Now there's an interesting property we can use with logs. Whenever you have a log to something and there's an exponent up here, you can actually bring this exponent right out in front. So instead it reads x log 1.06 equals. Now you can actually divide the log out. And that's what you get, equals x. So the final answer, and then you type that in on your calculator, I can show you, equals 92.7. But remember that it's only compounded yearly. So in his 92nd year, he's not going to have quite 100 million yet. Instead, he'll have it in his 93rd year. You have to round up. 93rd year. So 93 years.
Waking up to ash and dust, I wipe my brow and I sweat my rust.